This video will go over exponential growth and decay. The mathematical model for exponential growth and decay is the function f of t equals a sub 0 e to the kt. Now it is a function, and f of t is saying that the population growth is a function of t, which is time. So a sub 0 is the start amount. K is the growth or decay rate. If k is greater than 0, it's growing. If k is less than 0, there is decay, and t is the time. So we're going to have this exponential model, a equals 947.9 e to the 0.022 t. This describes the population of some country A in millions t years after 2003. We want to use this model to determine the population of the country in the year 2003. So before we start, do you know what the 0.022 represents? What 0.022 represents is 2.2% growth. This population is growing at 2.2% per year. One more point to make before we start is that our original function is f of t, and notice down here this is a. What a is referring to is the final amount. It is the same as our f of t. So there is a distinction between a sub 0, which is the initial amount, and a, which is considered our final amount. The question we're asked is, figure out the population of the country in the year 2003. Well, this model is used for the number of years after 2003, which means t would be 0 in that case. So if I put a 0 right here in for t, 0.022 times 0 is going to be 0. This is e to the 0th, and anything to the 0th power is just 1. So this just boils down to 947.9 times 1, which is 947.9, but remember this is millions. So what this is saying is that 2003 was the base amount before this population started growing, and using this formula. 2. The exponential models describe the population of the indicated country, meaning these, in millions t years after 2006. Use these models to solve these questions right here. Well, what was the population of Japan in the year 2006? This is just like the previous problem. Here is Japan's function. So we have 127.5 times e to the 0th, because if this is the year 2006, time is 0, all of this would become 0. And this is just like the last problem. E to the 0th is 1, so our initial population is 127.5 million. Same models. Now we want to know which country has the greatest growth rate. Remember that question about what did the 0.022 represent? Well, the 0.022 is a percentage that tells us what the growth rate is. This right here is 0.014, 0.027, 0.001, negative 0.004. The largest of these is this 0.027. So Iraq has the largest growth rate, and the percentage it is growing at is this 0.027, written as the percent, 2.7%. So Iraq's population is growing at 2.7% per year. The country that has a declining population is the only country with a negative value here, so that would have to be Russia. Same set. Now it says, when will India's population be 1,238 million? So we need to use India, and we're going to put the 1238 in place of the A. So finally we have to do a little bit of solving here. So this is 1238 equals 1095.4 e to the 0.014 t. We're going to be solving for t because it says, when will that population be 1,238 million? We have to solve this. If we're going to solve an exponential equation, the first thing we need to do is get this exponential part isolated. So divide both sides of the equation by 1095.4. So the left side now says 1.13, and this is e to the 0.014 t. Now, if I were you, I would leave this number, this whole number on your calculator. This is just rounded off so that we've got a number here, but this is obviously a lot longer. Leave the whole number on your calculator, and then let's solve this. And the way I solve this is I know I need to undo e, so I just take the natural log of both sides. The natural log of 1.13 is approximately 0.122. Same thing, leave the whole number on your calculator. The more digits you leave on your calculator, the more accurate your answer will be. ln e just cancels out, and we have 0.014 t. Simple one-step equation to solve here. Divide both sides by 0.014, and t is 8.7 years. Now, but Math Excel asks you to round this to the nearest whole number. So we're going to round this to 9 years. And if you add 9 years onto 2006, it'll be sometime in the year 2015. A new model is a new country, 245.3 e to the 0.002 t, t years after 2003. Use this model to determine when the population will be 253 million. This is just like the last problem. We will put 253 here equals 245.3 e to the 0.002 t. We need to isolate this exponential part. Divide both sides by 245.3. This is approximately 1.03, but I would leave the whole number on your calculator. This is going to give us e to the 0.002 t. Undo that exponential by taking the natural log of both sides. Squeeze that in there. The natural log of 1.03 is 0.0309. ln e cancels. We have 0.002 t. Simple to solve. Divide both sides by 0.002. And t is 15.5 years. Like the last one, Math Excel asks us to round this to the nearest whole number, so this becomes 16 years. That if we add that on to 2003, ends up the year 2019 is when the population will be approximately 253 million. In 2000, the population of Israel was approximately 6.04 million. And by 2050, it's projected to grow up to 10 million. Use the exponential growth model, a equals a sub 0 e to the kt, in which t is a number of years after 2000 to find an exponential growth function that models the data. Well, we have to do a couple things to do this problem. This right here is the initial amount. This is a sub 0. And this is our final amount. Now, it's as it correlates to the year 2050. So what I have here as an equation is 10 equals 6.04 e to the k. I don't know what k is. I don't know what this growth is. I'm going to go through this problem the first time here to find out what the growth constant is. But I do know that t is 50 years because we are saying from the year 2000 to the year 2050. So this is a 50 right here. Even though we're solving for k this time rather than t, solving it is going to be the same thing we did for the last couple problems. Divide both sides by 6.04, which will give us 1.655 e to the 50k. To solve this exponential, we'll take the natural log of both sides. The natural log of 1.655 is 0.504. ln e cancels, and we have 50k. Divide both sides by 50. And k is 0.0101. In your Math Excel directions, it tells you to round this to 2 decimal places. So really what we're going to use for k is just 0.01. And then we're going to make the model. The model will have a for a. We will use the a sub 0 value, which is 6.04. E to the k, which we know now is 0.01 t. This is the model that could be used to predict the number of people that would be in Israel in any number of year after the year 2000. Very similar problem. In the year 2000, the population of the Palestinians in the West Bank was 3.2 million, and by 2050, it's projected to grow to 12 million. So we're doing the same thing. We're going to write an exponential growth function. So 12 goes in for our a, 3.2 is our a sub 0, e to the k, which we don't know, but we do know that t is 50 because this is from 2000 to 2050. Get this exponential part by itself by dividing both sides by 3.2. This divides out to 3.75, and this is e to the 50k. To solve this, take the natural log of both sides. ln of 3.75 is 1.32. ln e cancels, and there's our 50k. Divide both sides by 50. And k is 0.0264, but keep in mind the Math Excel directions say to round this to 2 decimal places, so this rounds to 0.03. So now we're going to take this to write our function a equals the a sub 0 that we had, which was 3.2 million, e to our new k, which is 0.03 t. This is the function we could use to predict the population in the West Bank any year after the year 2000.